So in number 6, we want to solve logarithmic equations. Now, notice that it says find all real solutions. Real solutions, because remember, I'm just going to write this rule up here. For the domain of a logarithm, remember that the interior of a log must be positive. Meaning, if you have a log base a of x, your domain would be x has to be greater than 0. If x was negative, we could not take a log, and therefore there would be no solution, no real solution. And that's why our instructions say all real solutions. So we'll worry about that once we find our answer. We just have to make sure to check it. Okay, so solving logarithmic equations, we're going to use properties of logs. These guys all have the same base. That's great. Since I am adding, I can rewrite this as a single log where I multiply the two values that I'm taking the logs of together. And I'm going to leave the log alone on the right for now. Okay. Then, a nice property of logs, similar to solving exponential functions or equations, is if the bases of the logs are the same, then you can just set the interior of the logs equal to each other. So these are both base 10. Remember, if it's not written, we assume it to be base 10, which means I can rewrite this as just the interior of the logs equal to each other. Now, if I distribute the left side, I end up with x squared, quadratic. How do I solve quadratics? By factoring. I can't factor until I get a 0 on the other side of the equal sign. So I'm going to move the 16 over. And then this factors into x minus 8, x plus 2, which means my solutions, because I have 2 of them, are x is equal to 8 and x is equal to negative 2. Now remember, real solutions. So I want to check. Does x equal 8 give me a real solution? All you have to do is really quick plug in 8 back into the x's in the original equation and make sure that you get, it's a valid answer, right? So can I take log 10 of 8? Yes. Can I do log of 8 minus 6, so log 2? Yes, that works. X is equal to negative 2. Can I do log of negative 2? No, because the interior of a log has to be positive, and negative 2 is not positive. So I have one single solution, and that is 8. All right, in the next problem, we're going to start by combining our logs. So they are being subtracted, which means I'm going to write them as a single log, where the first term is the numerator, the second term is the denominator of a fraction. And then to solve this one, I'm actually going to convert this into an exponential function. So starting with the 3, I'm going to write it as 3 to the power of 2 is equal to this fraction. So that gives me 3 squared is equal to x plus 6 over x minus 2, or 9 is equal to x plus 6 over x minus 2. And I ran out of space, so let's just move this up here. Okay, so how do I get x out of the numerator and denominator? They do not cancel. I can't just cancel anything. Please don't break my heart by canceling things that you can't cancel. What we need to do is we need to get rid of the fraction. So I'm actually going to multiply both sides by x minus 2. So that the denominator and that value will cancel. No more fraction. Woohoo! I just end up with 9 times x minus 2 is equal to x plus 6. Okay, now I'm going to distribute the left side. And to get x, to solve for x, I'm going to group my x's together by subtracting x from the right and left to get 8x. And I'm going to add 18 to both sides to get 24. Divide both sides by 8. I get x is equal to 3. I know there's only one answer, but check that answer. There are going to be situations where you might have no solutions at all. So if I plug in 3 back to the original log problem, I only end up with positive interiors. That's good. So this